Hello there, welcome to my channel. Today we're going to be comparing these two numbers using calculus. However, before we do that, we're going to go ahead and use two alternative methods to compare these two numbers. And for that, we're going to use algebra. So basically, we're going to use three methods in total to compare these two numbers. And in the third one, we're going to use calculus for that. So stay tuned. For the first one, I'm going to go ahead and replace this with A and replace this with B. So in the first method, I'm going to go ahead and square both sides because that's kind of a natural tendency whenever we have square roots. So if I square A, I'm going to get A squared equals 21 plus 30 plus 2 times the square root of 21 times 30, which is 630. And if I square B, I'm going to get 31 plus 20 plus 2 times the square root of 31 times 20, which is 620. So I can say that A squared is 51 plus 2 times the square root of 630, and B squared is 51 plus 2 times the square root of 620. Next, let's go ahead and subtract B squared from A squared. So if you do that, we're going to get A squared minus B squared equals 51 cancels 51, so we get 2 times the square root of 630 minus 2 times the square root of 620. Now, it is obvious that the right-hand side is something positive, right? So that means that A squared minus B squared should be positive. And now notice that we can write A squared minus B squared as A minus B times A plus B. And remember that both A and B are positive numbers, therefore their sum is positive as well. So if this is positive, we can say that A minus B should be positive, which means that A is greater than B. Great. So this was the first method. Let's go ahead and take a look at the second method. Remember that we want to compare the square root of 21 plus the square root of 30 with the square root of 31 plus the square root of 20. Again, I'm going to go ahead and replace this with A and replace this with B. So A is root 21 plus root 30, and B is root 31 plus root 20. Next, let's go ahead and subtract B from A to get A minus B equals root 21 minus root 20 plus root 30 minus root 31. Next, let's go ahead and factor out a negative out of these two. So we're going to have A minus B equals root 21 minus root 20 minus the quantity root 31 minus root 30. Cool. Next, let's go ahead and multiply and divide this number by its conjugate and multiply and divide this number by its conjugate. So we will have A minus B equals root 21 minus root 20 times root 21 plus root 20, and then divided by root 21 plus root 20, right? And we do the same thing with the second one. So we have the square root of 31 minus the square root of 30 times the square root of 31 plus the square root of 30, all divided by the square root of 31 plus the square root of 30. Great. Now, if you use the difference of two squares identity, we can say that A minus B is equal to 1 over root 21 plus root 20 minus 1 over root 31 plus root 30. Great. And now we're going to go ahead and do something really beautiful. We know that root 21 is less than root 31, and root 20 is less than root 30. Therefore, we can say that root 20 plus root 21 is less than root 30 plus root 31. Next, if I go ahead and flip both sides, we will have 1 over root 20 plus root 21 is greater than 1 over root 30 plus root 31, which means that this fraction is greater than this fraction. And therefore, this difference is positive. Therefore, A is greater than B. Great. So this was the second method. Let's go ahead and take a look at the third method, which involves calculus. So again, we want to compare the square root of 21 plus the square root of 30 with the square root of 31 plus the square root of 20. Great. Now for that, we're going to go ahead and consider the function f of x equals the square root of x plus 1 minus the square root of x. So let's go ahead and find the derivative of this function because we want to use calculus, right? So f prime of x is going to be 1 over 2 times the square root of x plus 1 minus 1 over 2 times the square root of x. Great. Now notice that the square root of x plus 1 is greater than the square root of x, right? Which means that 2 times the square root of x plus 1 is also greater than 2 times the square root of x. And now, if we flip both sides, we get 1 over 2 times the square root of x plus 1 is greater than 1 over 2 times the square root of x. And if I move the expression on the right-hand side to the left-hand side, we will have 1 over 2 times the square root of x plus 1 minus 1 over 2 times the square root of x is negative. And guess what? This is f prime of x. So no matter what x is, f prime of x is always negative. That means that f of x is always decreasing, which means that if alpha is greater than beta, we can say that f of alpha is less than f of beta. And remember that f of x is the square root of x plus 1 minus the square root of x. So let's go ahead and replace alpha with 30 and beta with 20. If we do that, we're going to have f of 30 is less than f of 20. But what is f of 30? F of 30 is the square root of 31 plus, actually, minus the square root of 30. And f of 20 is the square root of 21 minus the square root of 20. Great. Next, let's go ahead and add the square root of 30 and the square root of 20 to both sides. If we do that, we're going to have the square root of 30 plus the square root of 20 is less than the square root of 21 plus the square root of 30. And remember that this is A and this is B. Great. So again, A is greater than B, and we used calculus to show that. And this brings us to the end of this video. Thank you for watching this video. Please consider subscribing for more contents like this, and hit the like button if you enjoyed watching this. Hopefully I will see you later. Goodbye for now.